this video, we will talk about free-falling object. First, what is a free-falling object? A free-falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in a state of free fall. Since those bodies fall under the action of gravitational force of the Earth, then the acceleration will be represented by g. G is equals to 9.81 meter per second squared or 32.2 feet per second squared. The motion of the falling objects is the simplest and most common example of motion with changing velocity. If a coin and a piece of paper are simultaneously dropped side by side, the paper takes much longer to hit the ground. However, if you crumple the paper into a compact ball and drop the items again, it will look like the coin and the paper hit the floor simultaneously. This is because the amount of force acting on an object is a function of not only its mass, but also area. Free fall is the motion of a body where its weight is the only force acting on an object. The best way to see the basic features of motion involving gravity is to start by considering straight up and down motion with no air resistance or friction. This means that if the object is dropped, we know the initial velocity is 0. Once the object is in motion, the object is in free fall. Under these circumstances, the motion is one-dimensional and has constant acceleration. The equations for objects experiencing free fall are the following.
Luke drops a pile of roof shingles from the top of a roof located 8.52 meters above the ground. Determine the time required for the shingles to reach the ground. The solution to this problem begins by the construction of an informative diagram of the physical situation. The second step involves the identification and listing of known information in variable form. The next step of the solution involves the listing of the unknown or desired information in variable form. In this case, the problem requires information about the time of fall, so t is the unknown quantity. The next step involves identifying an equation that allows you to determine the unknown quantity. Once the equation is identified and written down, the next step involves substituting known values into the equation and using proper algebraic steps to solve for the unknown information, and you will get your final answer.
Rex Things throws his mother's crystal vase vertically upwards with an initial velocity of 26.2 meters per second. Determine the height to which the vase will rise above its initial height. Once more, the solution to this problem begins by the construction of an informative diagram of the physical situation. This is shown below. The second step involves the identification and listing of known information in variable form. You might note that in the statement of the problem, there is only one piece of numerical information explicitly stated: 26.2 meters per second. The initial velocity of the vase is 26.2 meters per second. The remaining information must be extracted from the problem statement based upon your understanding of the principle above. Note that final velocity value can be inferred to be 0 meters per second, since the final state of the vase is the peak of its trajectory. The acceleration of the vase is negative 9.8 meters per second square. The next step involves the listing of the unknown information in variable form. In this case, the problem requests information about the displacement of the vase. So, displacement is the unknown information. The results of the first three steps are shown. The next step involves identifying a kinematic equation that would allow you to determine the unknown quantity. There are 4 kinematic equations to choose from. Again, you will always search for an equation that contains the 3 known variables and the 1 unknown variable. In this specific case, the 3 known variables and the 1 unknown variables are initial velocity, final velocity, acceleration, and distance. An inspection of the 4 equations above reveals that the equation on the top right contains all 4 variables. Once the equation is identified and written down, the next step involves substituting known values in the equation and using proper algebraic steps to solve for the unknown information. The solution reveals that the vase will travel upwards for a displacement of 35.0 meters before reaching its peak. The last step of the problem-solving strategy involves checking the answer to assure that it is both reasonable and accurate. The value seems reasonable enough. The vase is thrown with a speed of approximately 50 miles per hour. Such a throw will never make it further than 1 football field in height, yet will surely make it past the 10-yard line. The calculated answer certainly falls within this range of reasonability. Checking for accuracy involves substituting the calculated value back into the equation for displacement and ensuring that the left side of the equation is equal to the right side of the equation. Kinematic equations provide a useful means of determining the value of an unknown motion parameter if 3 motion parameters are unknown. In the case of a free fall motion, the acceleration is often known, and in many cases, another motion parameter can be inferred through a solid knowledge of some basic kinematic principles.